class, so we continue with the example 9.5, page 158. So this example is regarding the inferences, which is estimation and also hypothesis testing. So so example 9.5, okay, determine a 95% confidence interval for B. Okay, for B, B is stand for slope. In the regression line, y head equal to a plus bx based on the humidity data given in example 9.2. Okay, so we are using the same example 9.2. So 95%, therefore the alpha will be 0.05, is it? Okay, so for confidence interval, so we need to have here is B equal to B plus minus T alpha over 2 and then SB. So this is a formula. Okay. So like I mentioned before this, I prefer that you write first the what we call the formula, so that you know that what we want to calculate later on. So here you can see that we need to have B, T alpha over 2 and also SB. So we go first for SB. SB, the equation for SB here is given by SE over square root of SSXX. And SE is equal to SSYY minus B SSXY over N minus 2. Okay, so therefore you need to find your SE first. Then after you get the value of SE, you put it here. So then you will get your SB. Then you substitute it here. Okay. So we find first your SE. Okay, we find first your SE. And class, since this is example, by referring to example 9.2, we already calculate all the thing here as SYY, SSXY, and so on. We already calculated. So you just take it that value. Okay, so I just take the value. Okay, so 74 minus 0.2690, and B also, actually B also you already calculate. You already calculate not in example 9.2, but we already calculate in example 9.4, is it? If I'm not mistaken, yes, 9.4. Okay. So we already have the value for B also in example 9.4. Okay, so I just plug in all the value that we have here. Okay, N is 12, so minus 2 we get 10. So and then you will get here is 1.1014. So this is the SE value. So then we will substitute it here. Okay, so your SB will be 1.1014 divided by square root of, what is your SSXX? Is 85. I already calculate. So you refer your calculation. Okay, 854.92. So therefore the answer will be 0.0377. Okay, so this is your SB class. This is your SB. So we substitute all here. So B, okay, B here is 0.2690. Okay, how about this one? Okay, just write it first, 0.025. What is the degree of freedom here? The degree of freedom here is 10. Okay, and then your SB is given 0.0377. So we solve it this one. Okay, for this one you need to look at your T table. Okay, 0.025, and then the degree of freedom is 10, so therefore you should get 2.228. So you need to solve this one. Okay, we solve this one. So suppose that the answer that you should get here is 0.1850 and 0.3530. Okay, so this is the answer. Okay, so this is how we find the confidence interval. The step is equal, just the difference here is on the formula itself lah. Okay, the formula for these two, but the steps or the concept is still the same like we have done in chapter 6. Okay class, so now we go to the example. Next is example 9.6, page 159. Okay, example 9.6 now is regarding the hypothesis testing. Okay, it's about hypothesis testing. So the question here is, okay, based on the humidity data given in example 9.2, again we use the same example 9.2. Testing at the 10% significant level, can you conclude that B is different from 0? Okay, read carefully because you need to identify your H1 or H0. But usually that in the statement, in the question where it say that we want to conclude, so that will be the H1. Okay, that will be H1. So class, so we want to test, or we want to, hypothesis testing, we want to test on alpha 0.1, is it? It's 10%, so 0.1 lah. Okay, 10 over 100 will be 0.1. Okay, so step number 1, you need to write, or you need to state first what is your H0 and your H1. So as I mentioned just now, in the statement is already stated that can you conclude that B is different. So the word the word different here is the hint. So your B is different from 0. It's different. Okay, different from 0. So therefore this is the suitable sign lah, because this is not equal, right? So it's different. Not equal means it's different lah. So automatically your B will be equal to 0. Then step number 2, your test statistic. Your test statistic is given by B minus B as B. Okay, all these things you already have the value already. Okay, B is 0.2690, and this capital B, what I said in the previous video. Okay, I said that this is equivalent to your H0. Okay, actually in chapter 8 also I already mentioned that your B, or that one will be mu1 minus mu2. We can take it from your H0. So now your B is 0, and then how about your SB? Okay, you just take it the value that you already calculated here, which is 0.0377. So what is the answer that you got here is 7.1353. Okay, step number 3. Okay, just now is your alpha is 0.1. Therefore, what is your T? Alpha over 2. Okay, class, T alpha over 2. Why over 2? Because this is a two-sided. This is a two-sided. Okay, so T 0.05, and what's the degree of freedom just now is equal to 10. So by referring to the table T, so you should get 1.812. Then we sketch a graph. So since this is two-sided, so therefore they have two tail lah. Okay, there must be two sides of the rejection region. So this one is negative 1.812, and this is a positive 1.812. Okay, and then you check whether your T lies in the rejection region or non-rejection region. So 7.13 feet is somewhere here. So it means it lies on the rejection region, class. So therefore we will reject H0. So we will reject H0. So what we can conclude that, yes, we conclude what? What's the sentence just now? Can you conclude that B is different from 0? Yes, we conclude that B is different. If different from 0. We'll stop. Okay, alright. Okay, so basically it's the same lah, similar like what we have done in chapter 7, hypothesis testing, and also chapter 8. Chapter 8 is 4 to population, right? So that is the same steps and same concept here. Okay, alright. So class, one last. This is the last one is for this semester. Okay, alright. So exercise 9.3. Okay, so this is the very last one lah. Okay. So exercise 9.3 page 160 class. Okay, so the question here is, okay, this is not related with the example 9.2 already. This is a new one. Okay, a study is done to see whether there is a relationship between a student's grade point, average or GPA, and the number of hours that the student studies per week. Okay, then you can see they have a lot of questions here, A, B, C, and D, H. Okay, so what I can say for this type of question, so this is a type of final. I mean not the final. I mean will be the type or example of question that we can ask in your final. Okay, it will start with the first agenda, which is you need to determine the first objective, which is you need to determine the variable, independent, and then you need to plot a scatter diagram, find the linear correlation, and then find the least squares as well. So basically this question, exercise 9.3, is summarize all that we have learned in this chapter. Okay, so this is a type of question lah yang will be asked in your final or in your CAT exam. Okay, so given to you the data, hours and GPA. So their total is 7 data given here. So that's mean your N here is 7. Okay, then question A first. Okay, we do it one by one. So we do it for A first. So A, determine the dependent and independent variable of study here. So I just write down here X and Y first. So X is X is referring to independent and Y is referred to the dependent. Okay. Alright. So what's the dependent and dependent? So class, read it again. Question is GPA and also is relation between GPA and also number of hours. Okay. We already have this relation before in the previous example that regarding the result, right? Okay, so it's similar. So means that we know that if we give more effort or if we spend a lot of time to something that we like, so therefore we will have or we will get the good result for that, is it? So same thing. So if we spend more hours to our studying time, so we will possibility to get the highest mark or to get a good mark is high lah. So the result or the GPA here is depending on time. So what your depending just now I said is the GPA. So your GPA is depend with time. So this is the hours. Okay, so your X here is the hours that you spend or hour, and Y here is your GPA. Okay, done for first one. B. So B here is plot the scatter diagram. Okay, class, so just plot lah. Okay, so maybe you can plot by in the proper way lah. I'm just sketching here. So, but basically you need to have two axes here, X and Y. X is independent. So make sure kalau better you put this to term to make it or to avoid you careless when you plot the graph. So basically this X is hours. So hours, okay. So if you can see the hours is the minimum value is 3 and the maximum value is 16. So maybe and the gap maybe okay, maybe you can do 2, 4, 6, 8, 10, 12, 14 and 16. Okay, then for GPA the minimum is 1.69 and the maximum is 4. So maybe you can put 1, okay, 1.5, 2, 2.5, 3, 3.5 and then 4. Okay, it's up to you lah. How many the step size that you want to use. So for this I use 2. This one I use suppose it's 0.5 lah. Okay, I use 0.5. Okay, but it's up to you. And then you plot. Okay, you plot. So basically the graph that you should get here something like this. Okay, something like this. Okay, class. Okay. Okay, next is find the linear correlation. Okay, find the linear correlation, class. So this is R. Okay, again, better you write first the formula that involved here. So this is the equation, the formula. So you need to find your SSSY, SSSY. So all these things, first thing you need to find this lah. You need to find all these first. Okay, they have 6 items that you need to know first. Okay, right? So this is, you can use your calculator. I already show it in the previous example, in the example in linear correlation, okay, in the linear coefficient correlation, yes. So you can refer back to that video, and then after you get all the value, okay, I just, because I already calculate, so I just write down, I just write down, you check with my answer. Okay, so then, okay, the formula for SSXY is equal to summation of XY, summation of XY minus summation of X times summation of Y over N. So SSXX summation of X square times, minus summation of X square over N. SSYY, summation of Y square minus summation of Y square over N. So you need to substitute all this into this one by one. So I just write the final answer, okay class. So suppose that you should get 265686 1708571 4.8267. Then after you get all these three, you need to substitute it here. Okay, so after you substitute it, okay, substitute so 26.5686 over square root. Okay, square root is just for the denominator. 1708571 times with 4.826. Okay. Okay, I just write here, sorry class. Okay, I didn't have space here. So suppose the final answer for R that you should get is 0.9252. Okay, so yeah, 0.9252. So this is your R. So make sure you make it some interpretation, not interpretation, the last word lah. I mean, since you have this R, since your R is 0.9252, therefore this is the positive linear correlation. Okay, so better lah, better. I'm suggesting that you write here this. Okay, even though the question didn't ask it, but maybe sometimes question will give the question like this, make it a conclusion or whatsoever lah regarding the value of R. So your R is 0.932, so therefore this is the positive linear correlation. Okay, so we are done for C. So now we go to B, question B. Question B, question D. Find the least square regression line. Okay, this is what we call, what we have learned before. This y head A plus B S. So B is equal to S Y over S and A Y bar minus B S bar. Okay, so this one, these two, you already calculated before in the previous one. Baru je tadi kita dah kirakan. So just substitute that, the value that we have here, 265686 over 1708571. Therefore, the answer that you should get is 0.1550. Then how about Y bar? Y bar is summation Y over N. So what is it? What's the summation Y bar just now? Sorry, what the summation of Y? 22.11 divided by 7. Divided by 7. So therefore, the answer that you should get is 3.1586. And how about S bar? Is summation of X over N. So 76 divided by 7. So it's 10.8571. So you get all this. Substitute back into this equation, Y bar and minus B and so on here. 3.1586 minus 0.1555 times with 10.8571. Okay, class. So this one is equal to 1.4703. So this is not the final answer yet. The final answer here is you need to substitute again into your equation here. So your A is 1.4703 plus 0.1555x. So this is the equation of the least square regression line. Okay. Alright, next. E. Okay, E is come now it's come to the interpret the value of A and B. Calculate B. Okay, class. So again, like I suggest you before, you just use the same template. Okay, same template. Okay, you may refer back to the example 9.4. So use the same template as the answer in B. So the value of A and so on, blah blah blah. Okay, so you just change the value of A and value of B and also the variable that involved. Okay, so you change it. Because I want to write it, but my handwriting is so messy actually. So I hope that you can refer by yourself. In example 9.4, page 157, answer for B. So you just replace A and B, and also of course the variable you need to replace according to our example now, or our exercise that we're doing now. Okay, so I go to F. Okay, I go to F example now. F question. Predict the grade point average of student who studies 10.5 hours per week. Okay class, so this is your prediction. So your X will be 10.5. So you just substitute. So this is your equation just now. So just substitute 1.4703 plus 0.1555 and then substitute 10.5. Okay, you just substitute 10.5 over there. So the final answer that you should get is 3.1031. Okay, yes, I already calculated it before. Alright, so second last, G. So we want to construct a 99% confidence interval. So 0.01. Therefore, T alpha, which is T 0.05, because this is T.005, and how many the degree of freedom is 5. So by refer to the T table, that you should get 4.032. So to find the confidence interval, okay, B plus minus T alpha over 2 as B, and B you already calculated here 0.1555, and this is your T over 2, T alpha over 2. And how about your SB? What is your SB? SB? Oh, we didn't yet. Okay, so now we want to calculate SB. SB is equal to SE over SSXX, and SE is equal to SSYY minus BSSXY over N minus 2. Okay, so you just substitute. We already calculate right just now. SS blah blah blah, this one. So calculate it here. Okay, so I just write down the B. I write down the SE first. So SE supposed you should get is 0.3729, and SB you supposed to get 0.0285. Okay, so 0.0285. So you solve it, then you should get 0.4. So 0.0406 and 0.2704. Okay, so this is the confidence interval or estimation. Okay, now we go to H. Class, I use this space, okay, for H. Okay, alright, H. Test at 2.5. So that's mean your alpha is 0.25. Okay, this is your alpha 0.25. Then what else? What we need to do now? We need to, step 1 is write down the H0 and H1. So, okay, test at the 22.5% okay, significant level whether B is positive. Okay, the B is positive, class. B is positive, which is B is greater than 0. So this is the H1. Okay, this is your H1. Automatically your H0 will be less than equal. Okay, less than equal. So this is your step 1. Step number 2, you need to find the test statistic. So B minus B over SB, and B here is 0.1555 minus 0, minus 0, over SB just now 0.0285. Therefore, you should get here is 5.4561. Step number 3, alpha just now, okay, alpha is alpha is 0.25, and this is a one-sided, therefore it's just T alpha. So T 0.25, 5. Okay, so by refer to the table, you should get 2.571, and then when you sketch a graph here, because this is two-sided and it's a right, okay, right, greater than, so therefore it's in the right sided, 2.571. So this is the region class. So you need to check whether this T value lies or not. Yes, it lies. It will be it lies in this region, right? 5.4. So therefore we will reject H0. So step number 5, what we can conclude? Test at the level B is positive. Whether B is positive. Is it B positive? Yes, B is positive. Okay, B positive is H1. So when we reach H0, means that we will accept H1. So therefore, the conclusion that we can make is yes, the B is a positive. Okay, alright. So we are done. Chapter 9. At the same time, we are done. We finish our syllabus in statistic, engineering statistic. So I hope that you can get something like from all my videos. I'm apologies if my video is not perfect. Yes, because I'm not doing in maybe some lecture give in tab. Here the handwriting is so nice, but my handwriting is too bad for. But I really hope that you can get, or you can see what I want to deliver to you. Okay, class. Alright, so that's all from me, and all the best. Yeah, good luck. Bye.